So, hello everyone, we are back. So, our next speaker is Paul Turner from Canada. So, Paul Turner is a professional electrical engineer and a registered project management professional. He lives in Canada, as I said, and has worked in the power industry, wastewater treatment industry, and aerospace industry for about 20 plus years. And this time he had led commissioning of multi-billion-dollar projects and gained significant experience commissioning complex systems. He remains actively involved in commissioning of complex projects, as I said, while also sharing his commissioning knowledge with the community through online training. So we are very honored to have you here, Paul. So ladies and gentlemen, I present Paul Turner. Paul, the stage is yours.
Thank you, Hargeet. So today we're going to talk about better quality through advanced commissioning techniques. As Hargeet mentioned, I'm a professional electrical engineer and a registered project management professional. I've been working on very complex projects for the last 20 years. Some of the aerospace projects I've worked on are launching satellites and rockets for the Canadian Space Agency. I've worked on a 200 megawatt hydroelectric generating station in northern Manitoba. I was recently the commissioning manager for an HVDC transmission line, which was a $5.2 billion project that we delivered on time and on budget. And I'm currently working on commissioning a wastewater treatment plant. And through this 20 years of experience, I've been able to see what works and what doesn't work during commissioning in order to perfect an integrated commissioning method to ensure that commissioning is successful. Through the projects that I've worked on, I've seen projects go well and I've seen projects go very poorly. So it's become clear to me what works during commissioning and the best approaches for commissioning. And we're going to talk about some of those advanced commissioning techniques in this presentation. So what's clear is that we can no longer complete projects as we have always done them. Today's projects are much more complicated, much more complex than they have been in the past. With the automation systems, PLC control, distributed network systems that exist, the old way of commissioning projects no longer works, where the commissioning team just shows up for the last couple months of the project and tests the pump and the motor and puts a few things in service. That doesn't work anymore. Projects are much more complex. They're much more integrated. And we do need to take a more integrated approach to commissioning. Commissioning can't just be the last phase of the project for a few months. Commissioning really exists in every phase of the project. And that's what I want to convey with the integrated commissioning method, is that commissioning exists right from the beginning of the project, as early as project concept, when project sponsors are putting together chartering sessions and definition of the project. With commissioning, you really need to start with the end in mind. Commissioning is simply not just showing up at the end of the project and testing a few pieces of equipment. That can often be the mindset when projects are starting, is we'll get the commissioning team engaged at the end of the project and they can make this stuff work. But commissioning needs to start with the end in mind. You need to have that vision of what does it look like at the end of the project when you're signing final acceptance certificates and you're handing the keys over to the owner. That point in time, every decision leading up to there needs to consider that point in time as how is commissioning going to be successful to make that handover a glowing success. And to achieve the better levels of quality that are required on our projects, we do need to take into consideration how the owner is going to function with the system for many years in order to operate and maintain the system. We need to have that end of mind in focus to make sure that we're meeting the owner's requirements to achieve the quality levels that are required on the project. And that can only be done with an integrated process, to have commissioning involved in all stages of the project to start with the end in mind. From my 20 years of experience, it's clear that we need a new approach to commissioning. A lot of projects will spend all their time in the design phase and the construction phase, and unfortunately, commissioning is an afterthought, and particularly the software is an afterthought. Is the commissioning team will show up at the end, we'll get some PLC code, we'll drop it into the systems on site, and we'll be good to go. We'll just make it work. And that is not a path to success, and that certainly does not work. The commissioning team needs to be involved in the project as early as possible, right from the concept phase. That if you're hiring all the discipline managers for design, construction, commissioning should be on that list to involve the commissioning manager, that commissioning oversight early in the project. There's often that mindset of, well, it's always been done that way, so we're going to do it the same on the next project. And that's a risky mindset to get stuck in, especially since the last project was late and the last project was over budget. So why would we want to do it that way? We certainly need to think of new ways of approaching commissioning, so that we can set the project up for success. Certainly, we don't want to do it the way that it's always been done if the last project was late and over budget. There's lots of smart people in the commissioning industry, but the commissioning industry really lacks structure in order to define what is that integrated process from start to finish in order to make all these sequence of activities work correctly. Lots of people would know how to do a loop check and verify a particular piece of equipment, but what is the right structure from start to finish that all these activities need to take place in order that our commissioning projects are successful? Commissioning can no longer be an ad hoc process where the commissioning team shows up and tests a bunch of equipment and that's it. Commissioning, from my experience, definitely needs a structured process in how do all these activities fit together in order to make up a comprehensive commissioning program. So with the integrated commissioning method, what I've discovered is that commissioning has really not kept pace with the automation technology that exists in the market and the digital transformation that we're going through. Even the change that's taken place in the last 10 or 15 years, commissioning projects are still being approached as they have been, say, 20 years ago. And a lot has changed in the last 15 years. If you can imagine, 15 years ago, we didn't even have an iPhone. The pace of change is just astronomical. The number of things that are going to change in the next 15 years is even hard to believe. That the commissioning industry hasn't really kept pace with that digital transformation, and we do need to approach commissioning from a different perspective in order to take advantage of some of these technologies that exist, and as well improve our methods to be able to manage and adapt to these new automated systems that are being implemented in our projects. The commissioning industry is really behind and is only now starting to catch up to the transformation taking place. It's by definition can be a slow process. A lot of these projects can take 10 years to just get approvals to implement, and a lot can change in 10 years. So decisions that were made 10 years ago with a project that's just being handed over today are really outdated decisions. And because of that, it can be a slow process to adapt to the changing environment. But we do need to take a new approach based on what we know today for projects going into the future. Particularly for advanced digital systems, we do need an advanced commissioning process to implement these systems. With everything being interconnected, it definitely requires an integrated approach of how all the systems are going to fit together and function as one system. It's no longer the thought of you're going to test the battery system separate from the motor and pump and chemical dosing skid system. Everything's interconnected. Everything's got to work together, and it can only take one integrated approach to make all these systems function as one. We do need to address today's challenges with more sophisticated commissioning processes, and particularly take advantage of the sophisticated tools that can exist on the market. There's far superior methods to manage our commissioning projects to ensure that they function as intended. So the integrated commissioning method is really the blueprint that I have perfected to deliver my most recent project on time and on budget. And that was a $5.2 billion HVDC project, 1,400 kilometer transmission line from northern Manitoba to southern Manitoba. That really is the definition of a mega project with several projects within that mega project. And this is the method that we use to deliver that project on time and on budget. So let's go through some of the phases of the project and how we can implement these advanced commissioning techniques. Right at project initiation is when commissioning starts right at the beginning of the project. When the project team is putting together delivery strategies, procurement strategies, contracting strategies, those upfront fundamental decisions can significantly impact the outcome of commissioning. And that's the reason to have the commissioning team involved early in the project, is to help guide some of these decisions, where it may make sense at the beginning stages of the project to make some of these decisions, but if you don't have that end of mind thought process of how this is going to affect the end product, the handover to the owner, some of those decisions can severely limit the success of commissioning. And we just want to approach that from a whole project perspective, to have that commissioning phase in mind at the end and how this is all going to be successful. For example, through some of your contract definition, there may be a desire to split up contracts and have some economic diversity, and that makes sense from that perspective. But you also need to balance the fact that every time there's an additional contract, there's another technical interface to deal with between two different groups. And if you get to the point of having too many contracts, then commissioning can become unnecessarily complex and a lot more difficult later in the project. That's the thought process of how commissioning can help some of these upfront decisions and decide, how is this going to affect the end of the project. During the project planning phase, there's some critical decisions to be made that the commissioning team needs to have input in. When you're sequencing out the project, proper planning and execution of IFAT, which is integrated factory acceptance testing, definitely needs to be considered. Some of these decisions during the project planning phase are really de-risking the project and addressing some of the potential issues much earlier in the project that can certainly help to mitigate delays during commissioning. We need to be taking a risk-based approach when we're preparing our project sequences to make sure that we're not deferring all the risk to the commissioning phase of the project. Any things that we can advance earlier in the sequence and de-risk those items early in the project, that certainly needs to be the project planning mindset, so that we're not pushing all the risk to the commissioning phase and just saying, well, that's the commissioning team's problem, we'll let them deal with that. That can be very costly and add significant delays to the project. We definitely don't want to be doing that from a commissioning success perspective. Some of that will require advancing some of the design deliverables, and we'll talk about how that correlates to integrated factory acceptance testing in just a little bit. During the design phase, a few aspects need to be considered. Is when the commissioning team is involved earlier in the project, they can help to develop that overall commissioning sequence. So what systems are required in what particular order in order to build up the function of the system. So that commissioning sequence may define that the, let's say the battery system is required first prior to the next system, Definition of that commissioning sequence by the commissioning team, and knowing that sequence early in the project, particularly during design, is going to help to align all project stakeholders in the deliverables that they need to provide. So if the design team knows up front that the battery system is required first, well, then that would logically be the first system that they're going to work on for design to pass over to the construction team that will install that system first, and they'll hand that over to the commissioning team first. So an early definition of that commissioning sequence is going to help to align all aspects, all phases of the project, and that definitely must be taken into account. The other aspect during design is the operation and maintenance. Sometimes the design team may not necessarily have that operational background or maintenance background, but yet some of their design decisions are impacting how these systems are going to be interacted with for the life of the plant. Given that the commissioning team is the first group to start working with the equipment and operating it, the commissioning team can help give some of that advanced knowledge to the design group and help them understand how some of those design decisions are impacting operation of the system. Any of that information that can be conveyed earlier to the design group is certainly going to help commissioning if things can be optimized from an operational standpoint and a maintenance standpoint to make commissioning go smoother. Again, it's starting with that end in mind mindset to help some of the earlier groups in the project understand how their decisions are going to impact later stages of the project. A lot of the procurement decisions are established early in the project, and they have a critical impact on commissioning later as well. When you're establishing procurement contracts, sometimes it can be more of a focus on cost and lead time of equipment, but there's critical technical requirements in there that are going to impact some of the preceding activities and on-site commissioning activities as well. So in the procurement contracts, your integrated factory acceptance test requirements are going to be defined in those contracts in what you want the manufacturer to execute in the factory before the equipment leaves the factory and goes to site. So when you're putting together procurement contracts, you definitely need to consider all the technical impacts and requirements for IFAT in order that that's defined up front, and the manufacturer is going to proceed with testing in the factory as is required to de-risk the project. When you're looking at putting together all your procurement contracts, this of course needs to align with your commissioning sequence as well. And the critical part to consider there is when you're thinking about procurement, it's not just getting the equipment to site. You need to be planning your project to incorporate proper IFAT sequences and allow time for that to take place in order that that IFAT upfront activity can take place before the equipment gets to site. So this integrated factory acceptance testing is a critical aspect of commissioning. Often it's considered that this is off-site and it's someone else's responsibility to deal with, but IFAT is a critical part of commissioning, and I call it that way because I consider it commissioning. It's really the first testing of the equipment, and it's critical to address issues during this phase of testing so that the issues aren't deferred to site. Now, IFAT is a critical step of the integrated commissioning method and needs to be a focus of the project team because it mitigates the risk of the project so much more. Typically, in the past, 10 or 20 years ago, what would have been done is the focus on factory acceptance testing of the hardware. That's existed forever, but that no longer works for our projects when you're talking about integrated digital systems. The focus can't only be just on the hardware to verify that the cubicle has all the PLCs installed correctly and all the wiring is correct, and then ship it off to site. The critical aspect is that the IFAT must include both the hardware and the software. So that does require that the software design is available much earlier, but it's critical that both the hardware and the software are tested in the factory before shipping the equipment to site. In the past, it would have been likely determined, or would seem like a good idea at the time, that as soon as the hardware is manufactured, ship it to site so that we can get it installed quickly so that we're not delaying the project. But that old mindset doesn't work anymore. We need to be accounting for an integrated system to include the software in our factory acceptance testing as well. This is critical when planning out your project to allow time for that to happen. Because you could see how without the commissioning team's involvement, it would logically make sense that we want to get the hardware to site as soon as we can so that we can start to install it on site. In every instance that I've seen on some of the projects that I've worked on, that has never worked out well. What that means is that the hardware and the software are only meeting for the first time on site during commissioning. And essentially what you're doing at that point is still debugging the software. Having an integrated factory acceptance testing where both the hardware and the software are verified in the factory before it leaves to go to site verifies the hardware is correct, but also verifies that the software design is correct. When you're developing software, you're invariably going to find several issues, but that's the point of testing it during IFAT, is to determine those issues and get a stable version of software available so that when it finally gets to site, the commissioning team knows that or has confidence that the system is going to work. So I've seen some pretty complex IFAT test setups in the factory. On the last project I worked with, there was 30 PLC cubicles at the southern end of the line and 30 PLC cubicles at the northern end of the line. But when these are being manufactured in the factory, all 60 cubicles are in one room, test setup in the factory. Everything's wired together. The HMI screens are all connected up, and essentially you have a very condensed version of what the installation will look like at site. With this setup, it allows you to run all of your operating scenarios, all your normal operating scenarios, all your fault scenarios, normal operating conditions, fault operating conditions, functional tests, dynamic tests. You essentially put the system through its paces. The code is reacting accordingly and meeting the contract requirements. Any changes are much easier to make during IFAT. If logic changes, PLC programming changes, or changes to the hardware need to be made, this is the time to do it. There's more than likely more float in the project, and if changes need to be made, sequence in the schedule is much easier to accommodate. That's the time to address any issues with the hardware and the software. If that instead is deferred all until site, where you want to integrate the hardware and software together once the equipment arrives at site, then any errors that are found at that time are critical delay to the commissioning critical path sequence, and that can get quite expensive. We'll talk about that in a second. You definitely want to advance and de-risk the project by looking at all those items during your integrated factory acceptance test. Another 2 points that are critical during IFAT is it's really good to get the operators involved, the end user of the product involved during IFAT. Typically what's been done in the past, which no longer works, is the operators may see a screenshot of the HMI screens and they're asked to review them. The problem with that is that they don't get to see the functionality of the system as well. And IFAT is a great opportunity to have them involved in that. If they can see the HMI screens, if they can actually interact with them and see the function of them, that's the time to get the operator's input, because changes are much easier made during IFAT. If instead someone decides that it's not effective to send an operator to the factory to witness this, then the operators are only seeing the screens for the first time as equipment arrives at site. And at that point in the project is way too late to be making any changes to the HMI screens or function of the system. Essentially, those issues have to be deferred until a later point in time, meaning that the operators aren't necessarily pleased with how the with HMI screens are laid out. And that's never a good situation to be in. We want to get that input much earlier in the sequence. Another critical aspect of IFAT is to make sure that the commissioning team is involved in the IFAT testing. The commissioning team is the group that's responsible to work with this equipment for the first time on site, and having the commissioning team's involvement during IFAT allows the commissioning team to learn about the systems, become more familiar with the systems, and kind of know what they're going to be working with once the equipment arrives at site. Also, if there's issues that are discovered in IFAT, those will hopefully get addressed during IFAT, but invariably there may be some issues that need to be addressed later at site. Having the commissioning team's involvement during IFAT allows that continuity between off-site testing and on-site testing for any of those issues that kind of span both sites. So the commissioning team's involvement is critically important during IFAT as well. I do want to highlight the project burn rate because this becomes a critical consideration during commissioning. The construction phase of the project is always the largest cost of the project, where the largest portion of the budget, project budget, is spent. That typically could be maybe 80% of the project costs when all aspects of procurement, installation, and labor to complete the installation is considered. Commissioning is typically less than 5% of the project, the total project budget. It's typically in the order of like 2 to 3%. So from the cost of commissioning itself for the test equipment or the labor of the individuals involved, the cost of commissioning is generally typically pretty small. But the delay cost during commissioning can become astronomical. At the beginning of the project burn rate starts out low as the first design engineer gets involved and you start working with designing of the systems. The daily project burn rate can be quite small, but as you proceed through design and through construction and the total capital costs are increasing, adding on all the interest and escalation costs of the capital project, when you get to the commissioning phase, the daily project burn rate can be quite huge. On my last project, we were approaching $5 million per day in project burn rate. So what that means during commissioning is that every day of commissioning is essentially worth $5 million. So you need to be making rapid decisions and you can't afford any delays during commissioning. If something is missing and it costs a day to fix during commissioning, well, that's an expensive aspect of the project that you can't afford those delays during commissioning at $5 million a day. You need to be having all of this prepared in advance. You need to have de-risked all aspects of the project well in advance so that your focus is ensuring that every day of commissioning is successful. This needs to be closely monitored, and I do find that it can be helpful to raise this point when commissioning needs to be progressing at a rapid pace because of this project burn rate. Sometimes people might get bogged down and say, well, they need to save $1,000 or even save $10,000. Well, if saving that $10,000 is going to delay the project by one day, well, then that's a $5 million delay. And that needs to be considered when you're evaluating and making some decisions as you're proceeding through commissioning. Not so much commissioning, but given that construction is the preceding process to commissioning, a focus on construction quality is critically important. We need to be implementing the industry-leading quality management systems during construction. If the construction quality is poor, then that's deferring all the risk to commissioning to discover all these issues and try and make these systems work. We need to be looking to the construction team to be implementing industry-leading quality management systems. During construction, it can be somewhat overlooked that if there's a cable that's not pulled, well, no big deal. We can just pull that cable later. But the details matter during commissioning. That one cable could be a critical input to our PLC systems, and without that cable, without that I/O, without that input to the logic, the system will just not function. So consider the project burn rate. If the commissioning sequence needs to be halted in order for that cable to be pulled, glanded, and terminated into the PLC cubicle, even if that's just a one-day delay to commissioning sequence, that becomes a pretty expensive cable. If we're talking about our burn rate of $5 million per day, that a cable is essentially worth $5 million. And that's a pretty expensive cable. If that's the case on your project, you almost want to give that cable a special name and put up a plaque signifying the value of this cable, that this cable is worth $5 million. That's what we need to avoid, is focus on those details during construction through the QMS processes to identify any little thing that could be missing. A simple cable that wasn't pulled can become quite expensive during commissioning if those quality items aren't discovered during construction and instead are deferred to the commissioning phase. From construction to commissioning, it's defined as a mechanical completion. So this is the handover from the construction team to the commissioning team. The mechanical completions essentially define the construction priorities that the construction team needs to be working on based on the commissioning sequence that's been developed. Several mechanical completions are defined on what subsystems are required and when they need to be handed over to the commissioning team. And this is critically important to define is what the scope of each of these mechanical completions is. The commissioning team will be relying on certain aspects of the project to be available at a certain time to build up the commissioning sequence. And the mechanical completion process helps to define that so that expectations are clear of what's required and when it needs to be handed over. Another aspect in the transition from construction to commissioning is that the construction team will often be focused on installation of equipment, which they should be. So they're focused on installation of that transformer, and they're focused on the installation of that pump or that motor, which is great, but the mindset shifts from construction to commissioning in that one pump isn't very useful to the commissioning team on its own. It requires everything else around it for the motor, the electrical, all the mechanical piping. Everything needs to work as a system. The mechanical completion process helps with that, is that it groups all the equipment and says, okay, these dozen items form this particular subsystem. And therefore, that thought process changes from just item per item per item installation to an actual completion of a component of systems to form a subsystem. Even just one component missing from that subsystem isn't very useful to the commissioning team. We need to help change that mindset to know that everything needs to work as a group of equipment in order to function as a subsystem. And the handover process from construction to commissioning is extremely complex in today's projects with the complexity of all the automated systems that we're undertaking. This handover process does need to be executed with precision to set the commissioning team up for success. It really is a very complex symphony and needs to be orchestrated to precision to make sure that the right things are available at the right time. In some of the projects I've worked on, I've seen this go really well. In other projects, I've seen it go very poorly, and it's gone very poorly in every case where this handover process has been overlooked. It's easy to think earlier in the project that no big deal, once it's done being installed, then we'll go test it. And that's a simplified example, but that can't be the mindset, that we'll just wait for it to be done and then we'll go test it. The handover process can be quite complex as there's so many moving parts on mega projects. There's concurrent construction activities taking place with commissioning activities. One portion of the project may be energized for the first time by the construction team, but then another portion of the project is still under construction for the next couple months. And there's so much going on. There's so many moving parts that the handover process needs to be explicitly mapped out well early in the project to ensure that everybody's aware of what is required and when they need to be handed over. It's sometimes easy to think that certain aspects of the project may be delayed and we can hand that over to the commissioning team a little bit later. No big deal. The commissioning team can deal with that. They'll figure out how to resequence the project. But we have to go back to our burn rate example, as if a portion of the project was expected to integrate with the other portions of the equipment that the commissioning team is putting in service. While delay of that construction readiness component will effectively impact the project burn rate, as if the commissioning team is waiting for equipment turned over from the construction team, well, then that's certainly going to delay commissioning and impact our daily costs of commissioning. Despite everybody's best efforts, there is inevitably going to be delays, things that are not necessarily in everybody's direct control and are still going to impact the commissioning sequence, be it if there's long lead procurement delays, equipment that's being delivered later than expected, then the construction team isn't allowed enough time to install some of those items. We're still going to have to deal with infant mortality issues and initial equipment failure. And despite everybody's best effort, there likely is going to be delays. And when we're putting together our commissioning sequences, we need to be taking that into consideration, that some of these delays are inevitable, and we need to plan the commissioning sequence with some contingencies should this occur. When we're putting together our commissioning sequence, if we're expecting success through every aspect of the project, well, then that's setting yourself up for failure, because when there is an inevitable delay, you don't necessarily have a fallback plan in order to accommodate some of these inevitable delays. But one thing that I'll stress again that we talked about earlier is having the commissioning team involved early in the project, because establishing that commissioning sequence and some of those contingencies up front can certainly help to develop and mitigate the risk of the commissioning sequence being impact, and help the team kind of plan out those initial activities. We certainly don't want to be delaying things in handing over to the commissioning team, because those delays can become quite expensive, and we need to help everyone on the project understand how any delays like that can potentially become bigger problems during commissioning. So pre-commissioning is the next stage of the commissioning process, where we really pick up from what we completed during integrated factory acceptance testing. When the equipment is completed, IFAT, and everything is passed, and everybody agrees that the IFAT is complete, then the equipment is disassembled, all the cables are pulled apart, all the cubicles are packaged up in crates and sent to site. From that point in time when IFAT was complete and we knew that we had a functioning system, there's always the risk that something gets damaged during shipping and something gets damaged during installation. So during those two phases, we want to verify that no damage occurred, and pre-commissioning is the point in time when we do that. Once the equipment arrives at site and it's reinstalled in a permanent final configuration, pre-commissioning starts to verify that what we saw in IFAT is now what we also see during pre-commissioning on site. This differs from IFAT in that now we have everything was installed during the IFAT testing, as well as all the peripheral cables and all of the end devices. So we have full fidelity of the system, and we can now test all aspects of the system in its permanently final installed configuration. The pre-commissioning phase is essentially to confirm that we've got our installation back intact from what we had in IFAT, plus all the final configuration. A lot of the pre-commissioning checks are going to focus on the wiring, the cabling, the things that didn't exist during factory acceptance testing. So where you can find errors is in cables that are pulled, any terminations that are incorrect, and that'll be the focus on pre-commissioning, is to make sure that the cubicles can communicate with the end devices, that everything is essentially installed correctly in its final site configuration before we move to the next phase of the project here, where we focus on then functionality of the system. And that takes place during commissioning. So now that we've confirmed during pre-commissioning that everything is installed through loop checks, verification of installations, we can now start working with some of the complex logic functions with the real I/O from the end devices, and confirm that what we saw in IFAT is now functioning on site in a real world conditions. Some of the variations that would have existed from IFAT is we didn't have all the end devices in place. We were simulating a lot of those devices, but now that we have those devices installed in the field, we can verify all the complex logic functions during commissioning. If IFAT was done correctly, if it was properly planned and executed, then your on-site commissioning should go well. And that was the whole point of doing all the testing during IFAT, is that by the time we get to this phase of the project during commissioning, we have confidence that these systems are going to work. If IFAT was not done well, then all of the risk that was mitigated during IFAT is instead pushed to this on-site commissioning phase. And that's the critical point here, is that's deferring risk way too late in the project for today's complex systems. For these automation systems, you can't be combining the hardware and the software this late in the game, because instead of actually commissioning, essentially what you're still doing is just debugging the software. And where you thought commissioning was only going to take 1 week for a particular system, you can end up spending a month there of troubleshooting the system and debugging the logic and trying to make these systems work. And with today's complex projects, that is just not acceptable anymore. And it's not a project sequence that can be established. We need to focus on integrating those commissioning activities much earlier in the project. During the startup phase, since a lot of the risks were mitigated earlier in the project, the intention is that this goes smoother. Once we are introducing some of the process startup fluids, we should be, because a lot of the issues were addressed earlier, the startup phase should go much smoother. The startup phase is essentially going to be fine-tuning of the plant processes now that it's functioning, to adjust any operating parameters and ensure that its plant systems are operating as expected. Once we get the system started up, then the performance verification portion of the project really confirms that the owner is, the project is meeting all of the project requirements, and that the owner is receiving a contract compliant system. One thing to stress is that the tools that can support commissioning have evolved significantly in the last 10 years. I would say that even tools that were developed more than 10 years ago are outdated. They're not taking advantage of the technologies that exist today. The amount of information that is available on projects is just overwhelming with these digital systems, and paper and spreadsheets are no longer suitable to manage projects of this magnitude. There's just such an immense amount of information that what we're really dealing with is like Google size volumes of data, big data. Essentially, the social media platforms that we're working with are huge data sets, and we need to be leveraging this technology on our projects because there's similar volumes of data that are produced on the projects. The fundamental underlying architecture of some of the tools that are available on the market now are matching the tools that are available for big data analysis. And even if you've used some of these tools in the past, say like 10 or 15 years ago, and were somewhat discouraged that they weren't able to meet your project requirements, I encourage you to go back and look at what's on the market now, as the tools have advanced significantly, that we need to leverage these advanced tools to be able to help us manage our projects, to manage the big data and take advantage of the machine learning that's available. These tools are essential to commissioning success, to make sure that we can manage these complex projects. So one thing to point, and we'll just wrap it up here in the next couple slides, is that it's critical that we take a new approach to commissioning with our automated systems. They're way too integrated and way too complex to be commissioning the old way. We need to be de-risking the project much earlier in the process. Commissioning, and particularly the automation software, can no longer be an afterthought for development during commissioning, as we need to structure our projects properly in advance to de-risk the project and ensure that commissioning is going to be successful. So to conclude, as related to the integrated commissioning method, we need to be starting with the end in mind. We need to have that handover to the owner, that day in the project in mind when it's being handed over to the owner, and how we're going to get to that stage in all of our pre-project decisions to ensure commissioning success. We need to be taking advantage of the sophisticated tools that are available in the market today to ensure commissioning success. The commissioning team needs to be involved early in the project to help with some of these early decisions and ensure that commissioning is successful at the end of the project. And we do need to be integrating commissioning into all stages of your project to ensure commissioning success. So if you're interested in more commissioning info, there's a good resource that we've set up. If you're new to commissioning, you could consider taking my free three-day mini course. It's a good introduction to commissioning and the overall process from start to finish of how the commissioning process works. If you do have a few years of experience with commissioning and you're looking for a better way, more integrated process, you can explore more about the integrated commissioning method, and both of those are available at our website at commissioningandstartup.com. So I want to thank everybody for joining today's discussion, and feel free to explore any of the links below to learn more about me or more about commissioning.
Thank you very much, Paul. That was quite interesting presentation from your side, and I think you clearly answered a lot of questions while talking. So we have still a lot of questions right now, but we also have the next open forum round. So I would say, like, let's go to the open forum round at this instant and try to answer all the questions there itself. So see you in the next session.